Hi, and welcome to this session on Autonomous Database and the Data Lake. My name is Marty Gubar, and I'm a member of the product management team responsible for Autonomous Database's integration with the Data Lake. In this session, we're going to introduce you to a collection of features that vastly improve your data liquidity and data productivity. These autonomous capabilities simplify management, discoverability, performance, and scalability when analyzing data across your data estate. So I thought it'd be nice to start with an example of using a data lake with Autonomous Database. And this is a case that highlights the strength of both platforms. So CERN has a 17-mile long particle accelerator that's buried underground. And they are on a quest to discovering new particles to help them understand particle physics. So for them, their science platform needs to be extremely well managed. So the reliability of the control data and the speed at which they can gain insights from it are crucial to the science that takes place. Now, unplanned outages and unplanned repairs are incredibly expensive and require a multi-week cycle to warm up, repair, and cool down again. So this is an incredibly advanced IoT solution, and it's a complex mix of accelerators and detectors that persist and analyze data from more than 2 million signals. And this log data is measured in petabytes. So storage for the raw data is in the data lake, and it's transformed and it's then loaded into Autonomous Database, where that recent data is scored with machine learning models and allows them to predict potential maintenance issues, which is a critical component to managing their projects. Now, that's just one example. It's a great example, but it's one example, but there are many use cases for integrating the data lake with Autonomous Database. And here are a few categories, and they all revolve around the concepts of improving data liquidity, which is the ease of data reuse and recombination, as well as data productivity, or lowering the bar to get the most out of all of your data. So the first use case is really purely a cost savings. Maybe not the most exciting, but very important for the bottom line. And this is where the data lake contains a complete history of data, while the data warehouse contains the most frequently used information. So from within the warehouse, you may need to access all of that historical data, perhaps to answer regulatory questions or get one-off answers to specific marketing questions, right? So it's the ability to just, on an infrequent basis, go back and just ask questions in an ad hoc way. The second is extending the data warehouse to the data lake. And that's really improving the agility of the data warehouse by easily extending it with new metrics, right? So new metrics, new details or attributes that help you better understand your customers, understand processes, risk, and importantly, to be able to do this from within your existing applications. The third is multi-cloud, right? Customers have existing data lakes in AWS or Azure, and they want to make that data available to Autonomous Database. So the ability to reach out to these data lakes using Oracle SQL, either dynamically or through the loading of data. Now, these experiences would not be productive without allowing you to use your tools of choice, right? In your existing applications, whether it's Analytics Cloud or Tableau or Looker or Notebooks or REST, Python. So any application that supports the Oracle database and Oracle SQL benefit. We're calling this data unification the Lakehouse. And the Lakehouse offers an architecture that eliminates data silos. So it allows you to use both proprietary and open source tools to analyze all your data. Now, this is not, frankly, a new concept, right? Previous generations used engineered systems, right? Exadata and Big Data Appliance working together, right? I worked a long time on that platform and continue to do so, right? And, so they deliver very similar type of solutions, but we have now dramatically lowered the bar in terms of both complexity and economics, right? So you no longer have to pay for peak capacity. You pay for what you need, right? And you can deploy the solution in minutes, not weeks or months. So the Lakehouse is available to you now for any shape or size. So this Lakehouse is comprised of 5 key elements. You have managed open source services like Spark and Hadoop and streaming, data integration for orchestrating workflows and data movement and transformations. Now, we are actually going to be focusing more on these 3 areas, these 3 elements, which is you have your data lake that captures data in object storage, right? And it is a limitless, inexpensive file store. So it captures any type of file, images, documents, Word documents, PowerPoints, CSV, Parquet, any type of data. It's just files being saved into a file store. And it can contain data sets that are of unknown value or sparse data sets that may contain interesting signals when analyzed, but it's, could be processing intensive to get to those signals, right? Because you're analyzing vast data sets. Now, the data catalog provides centralized metadata for these unstructured files. So it's turning these files into something more meaningful, deriving technical metadata like tables and columns and data types from these files, as well as allowing you to apply a business context and semantics. So, these files may contain customer data that was last updated on Friday. It's bronze, which means it's not yet certified, but can be used for analytics, right? So this is the additional business context that one can apply to that data using the data catalog to help you understand the meaning of that data. And then finally, we have, of course, the data warehouse. So the data warehouse is storing the data that you use to run the business, right? It contains both curated and trusted data that's going to be used by hundreds, if not thousands of users that require fast, consistent query performance. So let's drill down on these last 3 areas. Oracle has introduced a collection of autonomous database features that simplify access to the data lake and then scales out queries against data lake sources. These features take advantage of data catalog and the rich centralized metadata, eliminating the need to manage data lake metadata in autonomous database. Now, once you have database tables linking to object store data, you query that data as you would any other data in the database. They're just tables. Autonomous database then speeds up the data lake queries using specialized processing designed specifically for object store access. So, as I mentioned, data catalog is the source of truth for metadata in the data lake, right? So it greatly simplifies the definition of this metadata through a harvesting process. So data catalog will scan the object store. It derives technical metadata, folders, logical entities or tables, columns and data types, and any number of entities can be derived during a single harvest. Now, once harvested, tag that data, assign business terms to it, associate glossary terms to it. And Data Catalog makes that process of the application of business context easier by using machine learning to offer suggestions, right? Hey, I think this entity really is sales information, right? And it does that. You can then do that quick association. So it really simplifies that process. So I mentioned this in the context of object store sources, but the same concepts apply to data in your databases, right? Or data in Hadoop, or streams, right? So Data Catalog can harvest not just object store, but databases and other sources as well. So now that your technical metadata is enriched, you use Data Catalog's search capabilities to discover and understand your data sets. So when were they last updated? What is the reliability of the data? Maybe you only use this data for experimentation. This data is actually trustworthy and can be used for regulatory reasons. Yeah, what is the meaning of the individual fields? Now, autonomous database, or frankly, multiple autonomous database instances, connect to that data catalog and automatically leverage that shared metadata. And that metadata appears in autonomous database as fully managed schemas and tables whose source of truth is the data catalog. So if there's a change in data catalog, maybe a new field was added, that will automatically be refreshed in autonomous database and reflected there. You can even query the metadata using SQL from autonomous database. So within the context of ADB, you can say, hey, I want to find all entities having to do with customer, and just run a query against a data catalog to find that. Okay, now that you have your data accessible through Oracle, hey, ask questions. Ask questions that span the data lake and the data warehouse. And you can use Oracle's powerful SQL language from your existing tools and your existing applications without any changes required. Right? Those applications are just going to work. And I can't stress enough the importance of a rich analytic language. Not all SQL implementations are the same. So for example, let's say without SQL pattern matching in Oracle, you will need to use Python or Scala or Java to write, debug, and run code to understand a sequence of events, right? Now with Oracle SQL, it's declarative, right? You write a query using SQL pattern matching. You run your query, you tweak it, run it again. So having a rich SQL language keeps you from falling off of a complexity cliff, right? You can just enjoy the view and dramatically improve your data productivity. Finally, Autonomous Database allows you to query these data sets at scale. So Autonomous Database provides specialized object store processing. And the whole purpose of that processing is to scan, filter, apply functions, and aggregate data that's in the object store. And it's automatic, right? There's nothing that you need to do. It only engages when required. So this specialized compute is isolated from your database cores. So it reduces the impact on your database workloads. So how do you make it work? Well, the only thing you need to do is enable autoscale on your autonomous database. ADB will then do the rest, and you'll only pay for what you use. So let's take a look at it. Right, we're going to use an example solution called Oracle Movie Stream, which is an online movie stream scenario to see how this whole process works. It will show you data catalog, harvesting, and querying across the sources, all from within notebooks. And you can do this yourself, right? So we have live labs available to you. You just click on the URLs that you see in the bottom right here, and you can try it and see how it all works. So let's head over to the demo. Okay, so our demonstration is going to start in our Autonomous Database Machine Learning notebook. And, we're Oracle Movie Stream, and we are an online movie streaming service. And basically what we want to do is better understand our customers. Who's using our service? What types of movies are they purchasing? Etc. And what we're going to do is we're going to show how you're easily able to combine information that's in your data lake with data that's in your data warehouse, and also help you find the information that you need to successfully analyze your data. All right, so we're starting with looking at information that's in our warehouse, right? So I'm running this query of my top sales broken out by city. This is coming from my warehouse, and I can see, all of the sales information for these top cities, and New York is clearly by far the leading sales. And when I drill into that, what other information do we have about customers in our warehouse? And basically, when I look at our customer data, we have customer contact information, right? So here we're just saying, hey, let's select everything from customer contact, and we have our last name, first name, mail, email address, where they live, how long they've been a customer, do they respond to promotions. So, some very high-level information, but it doesn't necessarily give me a flavor for our user community, our customers. Who are they? What do they like to watch necessarily? So let's see if there's other information available to us that can help us better understand customer profiles. Now, to do that, I'm going to start by saying, hey, we have a data lake, right? And our data lake captures information in the object store. This is a picture of the object store. We have buckets. We have our gold zone, a landing zone, a sandbox. If I look at the landing zone, these are files, right? Files have landed. We have that customer contact information. Oh, we have some third-party data. We call it customer extension. We also have pizza locations because we partner with a third party for local promotions. So we have this information that's in our landing zone. And then we have what we call our gold zone. This is our curated part of our data lake, where we have things like sales to existing customers broken out by movie and genre. And if I look at my customer sales, you can see this is an optimized format, right? We have it broken out by month, all these partitions. And then when I look in a given month, I have this data stored in Parquet format. So I have a very efficient way of storing my data in the data lake. So I have files, I have folders. That's basically what I have. I want to understand this data more. So I'm going to go to the data catalog. Now, the data catalog enables me to define what we call data assets, right? So I'm going to go to the data assets, and you can see that I have one called the data lake and another called our data warehouse. So to a data asset, data catalog supports numerous data assets. So you can create a data asset over Hive, autonomous data transaction processing, DB2 Kafka, Azure SQL database, all these different sources, including Oracle Object Store. So that's what we've done here in the data lake, is that we've created a data lake asset. We actually harvested that source, right? So we connected to it. We created this asset, and then we went through what we call a harvesting process that collects information about that. So you say, hey, I'm going to run a harvest over my source, let's say over this landing zone, and say, yeah, I want to actually harvest everything in that bucket. Okay, so it's now going to scan that source. It's going to scan the landing zone. And what it does is it will derive what we call logical entities and folders. Right? So if I go to the data lake, we can see that gold zone, that landing zone. And within the gold zone, for example, we have, I can drill down on it and see my customer sales, my customer contact information, information about movies. Well, I'm really interested in searching, actually, for information about customer. So I could have thousands of logical entities, but I really am interested in stuff about customer. So here's all the stuff that's coming back about customer segment, customer contact, lifetime value of my customer, right? We have 57 items actually that have come back. And I'm going to refine this search and say, well, I'm really interested in things that are coming from the data lake that are what we call logical entities. And when I look at my different logical entities, I see, in the object store, we had that customer extension. You remember we saw that folder. And if I look at customer extension, customer extension actually has some really interesting attributes about my customer. Let me get a better or fuller view. Their household size. Are they married? Do they have a mortgage? All this is third-party data that we purchased. It's not part of the warehouse necessarily. It's just in our landing zone. And if we go back and look at a summary of customer extension, you can see its description that says, this is demographic data from a third party and it's approved for analytics use. Okay, that's great. So this is customer extension is some interesting information that I may want to look at within, I may want to start querying from within ADB. So I'm going to go back to my machine learning notebook. And I actually went back here and I queried the object store directly from within Autonomous Database. I said, hey, I want to select all of the entities that have something to do with customer. Right? So this is a query that's going back to that same data catalog instance, right? And you notice that when I scroll down at the query result, you can see that customer extension data in the landing zone. Its classification is silver. Its customer demographic details approved for analytics use. That's what we just saw. And here is actually within Autonomous Database, the schema and the table name within ADB that I can now query. So we also have something called customer segmentation that is another table that is interesting that came from our data lake. And this has been derived by our data science team, right? And what they did is they segmented our customer base based on these various attributes and how they map to our data sets, right? So now if I want to look at my customer segmentation, right, here you can see a breakout of them under 22, single females. This is a query that's it looks like any other select statement that is going against Oracle. In this case, it's getting customer segment from this managed schema called the landing zone. And when I go to look at the customer demographics, all that information that we just saw in data catalog described is right here. Their email, their age, their commute distance, their credit balance. So this is simply a query against that demographic data coming from the data lake. Finally, I can combine that information. I can say, hey, what I'm going to do is I'm going to look at that customer contact information coming from the warehouse, and I'm going to combine that with information coming from my data lake. So at this point, I'm just running queries against both the data lake as well as the data warehouse, with frankly not having to worry about the fact that, customer extension is a Parquet file, or a series of files. Customer segment is, I don't know, CSV. You don't care. You're querying this data like you would any other data, and you're combining it. So now this is a report that is blending both. At this point, I can run a query that says, hey, I'm now going to look at my customer sales data, combine that with genre information and that customer segmentation and that those customer demographic information, and I get a much better view of my customers. Like double income, no kids seem to be very much interested in dramas, whereas if you're under 22, adventures are more interesting. Divorced and widowed people are looking for a laugh, right? So, it's a way of, we've just now started with data in our warehouse. We said, okay, I want to find information that can give me different kind of insights into my customers. Who are they? What are they buying? Who's at risk? We have other queries below. They're saying who's at risk, et cetera, right? All of these queries are blending information from your warehouse with data that's in your data lake, and you're doing this seamlessly. So in a nutshell, here's the major takeaways. The Lakehouse is a system that enables us to look at our data in totality. Autonomous Databases integration with the data lake that lets you automatically leverage the metadata, the centralized metadata that's in your data lake coming from the data catalog, removes the management required for accessing that data from within the data warehouse. It automatically defines managed schemas and tables, and then you unleash Oracle SQL on top of all of that data. And you do that efficiently by scaling out queries using specialized processing. So I hope this was a helpful session. I thank you very much for attending, and I hope you have a good time at the rest of Database World. Thanks a lot.